Just very quickly, a couple more things that you should know for TSW number 1. You will find them in the written class notes, but I wanted to voice them here in this video. We measure electrical charges in units which are called coulombs. So 1 coulomb would be, a standard unit that we would use for measuring electrical charge. Just like we measure distances in meters, time in seconds, we measure electrical charges in coulombs. And 1 electron or 1 proton carry the same amount of charge, but opposite. It is not 1 coulomb. It is much, much, much less than 1 coulomb. You don't need to know how much it is right now. Just remember that 1 coulomb is actually a charge of many billions of electrons and protons. So 1 coulomb is a relatively large amount of charge. And if I had, 2 charges of 1 coulomb positive and 1 coulomb negative, and place them 1 meter apart, the force of attraction between those 2 charges would be so large that I would not be able to hold these 2 charges of 1 coulomb each, distance 1 meter apart from each other. So electrical force is compared to the force of gravity, it's a billions of times larger or stronger force. And you can kind of feel that when you jump off of a really, really tall building. It takes the force of gravity several seconds to bring you down to the earth. But the time it takes the force of the electrical force to stop you down, so to decelerate you from, let's say, 200 meters per second, I guess it's not 200 meters per second. I think the terminal velocity for a falling human body is about 230 kilometers per hour. So it takes several seconds for the force of gravity to accelerate you to that speed. But then when you hit the ground, and by the way, don't try that at home, don't try that. When you hit the ground, the electrical force will stop you in a matter of a fraction of a second. So the force that it decelerates you is many, many, many times larger than the force of gravity which accelerated you. Of course, we measure both electrical forces and magnetic forces in newtons. So any type of force would be measured in newtons. Force of gravity is measured in newtons. Electrical force or magnetic force are, together we call them electromagnetic force. They're also measured in newtons. Remember also that an electrical field is an invisible force field that's surrounding any charge or any charged object. And if a charge is moving, then it is surrounded also by an invisible magnetic field, which is also an invisible type of a force field. So 2 types of force fields connected with charges. One with static charges, not moving charges. Okay? Surrounding this static positive charge would be an electrical force field. If the charge is moving, then it is also surrounded by another type of a force field, which we call a magnetic force field.